In this problem, they have given you box of x plus box of x plus box of x is equals to 12. As I mentioned previously, that whenever this sign is given, they will always mention you that it is the greatest integer function. Otherwise, you will treat this bracket as a normal bracket. In this question, if you observe, you will find that they have already given that this is nothing but the greatest integer function, right? Now we know one formula that box of x plus I is an integer, can always be written as box of x plus I. Is it clear? Now if you observe this sum, you will find, forget about every other box, just see this much. In this we are having box of x plus box x. Box of x is an integer. So for this we can write, for x plus box x, we can write it as box of x plus the integer, which is nothing but your box x. Am I correct? So this thing will give you what? Box of x plus 2 box x is equals to 12. Now 2 of box x is again an integer. So we can write this thing as box of x plus 2 box of x equals to 12. So that implies 3 box x is 12. That implies box x is 4. Now if box x is 4, then x belongs to, if box x is 4, then x belongs to greater than equals to 4 or less than 5. Therefore, the solution for this equation is x belongs to closed 4, open 5, and that is the solution. That is the answer for this sum. Is it clear to everybody? Now in this problem they have given us 5x plus 3 fractional part of x equals to 4 times 2x plus 2 minus 5. Is it clear? Now again I am telling you, these brackets are the special functions because it has already been mentioned in the question. Otherwise I would have considered these brackets as our normal brackets. But in this case they are the special functions. This is the fractional part of x and this is box of 2x plus 2. Now we can write this thing as 5x plus 3 fractional part of x equals to 4 times box of 2x plus 8 minus 5. So we are getting 4 times box of 2x plus 3. Is it clear? Now you see one thing, 2x can be written as 2 times box x plus fractional part of x. Am I correct? Because as we all know that any x, any real number can be written as box of x plus fractional part of x. Therefore, that gives you 2 box x plus 2 fractional part of x. That implies box of 2x is nothing but box of 2 box x plus 2 times fractional part of x. Now 2 box x is again an integer. So I can separate it, box of 2 fractional part of x plus 2 box x. Is it clear? So box of 2x can be written as box of 2 fractional part of x plus 2 times box of x. I am replacing this in my given equation. So what we are going to get? Four times box of 2x, I am replacing it by that. So box of 2 fractional part of x plus 8 box x plus 3. So we are getting what? Again you see, this x can be replaced by x can be replaced by box x plus fractional part of x. So we are getting 5 box x plus 5 fractional part of x. 3 fractional part of x is there, equals to 4 times 2 fractional part of x plus 8 box x plus 3. So we are getting what? If I take 5 box x in the right hand side, we are going to get 8 fractional part of x equals to 4 times box 2 fractional part of x plus 3 box x plus 3. Hello? Have you understood this? Okay. Now we will consider 2 cases. The first case is we are assuming that fractional part of x is lying between 0 and half. Why it is so? Because 2 times fractional part of x will now lie between 0 and 1. So 2 times fractional part of x is nothing but a fraction when your fractional part of x is lying between 0 and half. If 2 fractional part of x is a fraction, so box of it will give you 0. So for case 1, this is our case 1. So for case 1, our equation is coming to 8 fractional part of x, this part will give you 0, equals to 3 box x plus 3. From this equation, this part is 0, so 8 fractional part of x is nothing but 3 box x plus 3. Therefore, fractional part of x is coming to 3 box x plus 3 divided by 8. As we know that your x, fractional part of x is lying between 0 and half, so we can write 3 box x plus 3 divided by 8 is lying between 0 and half. Am I correct? So if I multiply with 8, we are going to get 3 box of x is greater than equals to minus 3 less than 1. So box x is lying between minus 1 less than 1/3. Is it clear? So your box x is lying between minus 1 and 1/3. What are the integers that box x, because box x is an integer. Box x is an integer. So what are the integers that box x can take in this form? In this condition, what are the values of box x can take? Okay. Here, your box x can take the values, since it's an integer, so it can take the value minus 1 or it can take the value 0 in this range. Is it clear? If box x is minus 1, put it here. So we are going to get your fractional part of x as 0. And if box x is 0, we are getting fractional part of x as 3 by 8. Now, as we all know that x can be written as box x plus fractional part of x. So we are getting 2 values of x in this case. One is minus 1 and another one is 3 by 8. Is it clear to all of you? Can I rub it? Okay, so case 1 is that x can take the value minus 1, 3 by 8. I am writing it here. From case 1, we got the values of x such as minus 1 and 3 by 8. Okay, now let us consider case 2. What is your case 2? Now in this case we will say that this is case 2. Your fractional part of x is lying between half and 1. So in that case you are getting 1 less than equals to 2 fractional part of x less than 2. Is it clear? Therefore, box of 2 fractional part of x will give you nothing but 1. Am I correct? Okay. So the equation, this equation becomes for case 2 is 8 fractional part of x is equals to, this thing can be replaced by 1. So it is 4 plus 3, that gives you 7. So it is 3 plus 7, that gives you fractional part of x is nothing but 3 box x plus 7 divided by 8. Am I correct? Again, your fractional part of x is lying from half and 1. So 3 box x plus 7 divided by 8 is greater than equals to half less than 1. Cross multiply. subtract it. Okay, in this case also we are getting that box x is lying between -1 and 1/3. And what are the integral values that box x can take between this range? Your box x can take the value -1 and 0 again. Is it clear? Now if box x is -1, if I put it here, we are going to get your fractional part of x as half. Is it clear? And if I put box x equals to 0 in this equation, so we are going to get fractional part of x as 7/8. Therefore, your x, the values of x from case 2, we are getting it as -1 plus half, that is minus half, or x can be written as 0 plus 7/8, which is nothing but your 7/8. Am I correct? So the required values of x are, one, we got -1 and 3/8 from the first case when we have considered that fractional part of x is lying from 0 and half. And in case 2, when we have assumed that fractional part of x is lying between half and 1, we are getting the values of x as -half and 7/8. So from case 2, we are getting x as -half and 7/8. Is it clear? So we got 4 values of x which will satisfy this equation. They are -1, 3/8, -half, 7/8. Is it clear to all of you? Absolutely clear? No question? You have to revise this sum twice, at least twice. Then only you can understand. And the moment you can do this sum by yourself, first you see, no problem. First you understand. Then you try to do the sum by yourself. The moment you can do the sum by yourself, you will gain that confidence. And that will boost you to do other sums, other harder sums, more harder than this kind of sums. Is it clear? Understood? Okay.